Hey, good evening. It's day 81. Um, feel awful today. Had that interview I talked about for the student position for a data science intern and bombed it. I mean, guy asked what the difference between a process and a thread was, and I just froze up. And it's like just like a simple computer architecture thing. Like I couldn't think of like a formal definition of either of them, and then I couldn't think of it. The only thing I said, I was like, oh, like I know a thread is like works in its own like core or something like that. I'm like, I literally couldn't think of anything, and then he started like talking, and I'm like, what am I saying? Like a thread like runs within a process. A thread like shares memory and like doesn't get its own like resource or memory space. It shares with other threads. When a process is like independent of everything. It's its own, own memory space and all of that. I literally looked over the difference between multi-threading and parallel processing before that to make sure that I was like set on that. Because I've been asked that before, and it was like, yeah, multi-threading. It's that exact answer actually. Is just like, yeah, in parallel processing, you use different cores to do like things. I mean, in parallel, right? But they're all like independent, sort of. And but multi-threading is like, I mean, threads share the same memory space and resources, um, and that's the main difference. Um, and I just completely blanked, and so that was horrible. Step number one, and then he started talking about like a technical question, and I was so caught up in like, oh, I need to redeem myself here, and so like he was like saying, oh, if you have a um if you had like a data set of all of the names, last name, date of birth, social security number of like every single person in the United States, he was like, return how or how can we find out how many unique names there are in the United States? And so he like then started explaining it more and more, and I completely forgot about the unique part. And so I thought he was just like return like the amount of names in that, and I'm like, okay, you can just like use pandas, read the file, right? And then for each line, do like a regex expression matching, look for the first name, like the text before the first comma. And then I was like, you could use a dictionary and make each name like the key or something like that. And so obviously he's looking for a set there, then you like return the length of the set. But at first I was like, I don't really know. I didn't understand what he was talking about in terms of like uniqueness because I thought I heard more than just like return the unique stuff. And so then I just look like an idiot because I'm like, because he's like, yeah, maybe you could. And he's like, but is there something better? And like, I like asked for clarification. And then I'm like, I guess you could use an array and be like, well, actually, I said, I bet you could use an array or a set or something like that. But if you use an array, you just like check each value for if it's in there, which obviously you wouldn't because that'd be so like disgustingly time complex to for every single one check. Um, But at the same time, I mean, what is the time complexity of like of a pending two? Is it just O of one? Um, um, if you have a set, it's not your full complexity, is it? Maybe. I think it's just two. Okay, so on average, it's an O of one. And then this should be O of N, right? Yeah. Okay. So it's more efficient. That's what I assumed. I just wanted to make sure, I guess. Anyways, so those were the two technical things he asked. And so obviously, those are very easy technical things, and I stumbled on both of them. Eventually, I got to the answer on both of them. Um, but I mean, the first one, I don't even know if you can say that because he literally said like, oh, a thread has its own resources, and I'm like, oh, and then I like went into like I tried to cut him off and say as much as I knew, as soon as it clicked, but I mean, I think at that point it's just far gone. Um, Sucks. Um, Gosh, like I mean, it just feels awful, you know. Um, yeah, I don't know. I The only thing I can do is work harder. Um, I need to be putting more time in, just period. If I obviously I'm getting like no interviews, and so now when I am getting interviews, I can't be doing something like that. So yeah, I don't know. And I don't know. It's always the stuff that always trips me up because I'll be honest, if I got that first question like fine, what I said for that second one was fine. It was like, yeah, I need some clarification. But the fact that it was followed up by like how badly I like answered the process versus thread, that's what made it look really bad. So it's not even like technical stuff. Like if I got an actual coding problem or like something like that, like even like system design, it's just when they're like I just have such a hard time with like exact definitions of things within computer science. Like really, like that is easily the thing I struggle the most with. Um, and I don't know if that's just a lack of studying, a lack of, I mean, it has to be, right? How else am I going to get better at it than just like reading up on stuff? I don't know. So I don't know if I want to incorporate something into these videos where we're literally just reading up on CS topics or something like that because yeah, I don't know. Those are easily like I'd say that, and also I do like think like the way I present myself in interviews isn't that flattering. I think I sound decently robotic, and I like um I don't know. I feel like that I have something that's definitely missing um in my interview skills. So yeah, it 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 sucks. Um, not much more I can say about that. Yeah, so just gotta work harder, do more. Um, because I mean, I'll be honest, I don't think I'm getting an internship this summer. I mean, this has been horrible. I haven't gotten a single actual summer intern. Like this was for a spring intern position at my school, so technically I still haven't gotten a single interview for a summer thing, and it's been September, October, November, December, January, February. It's been almost a full 6 months. And I think I maybe started late August, so it's been a full 6 months of this, um, and not a single response. Um, so yeah, um, I've kind of given up on the hope that I mean, I'll still apply to stuff, but I mean, it is. I don't know how I can have any hope with how horrible this has gone. Um, so I guess I just have to have my sights set on applying for full time stuff throughout my senior year. And you know what that's going to look like. I want more. I mean, if I'm not getting any more experience, it has to be projects. So obviously, I need to be doing projects that are insane, like would actually make someone go, "Wow, I need to." That was the whole. That was honestly the whole point of me saying like I want to like try to make my own operating system, which as time passes is still just stupid to say, but I don't know. Still would like to take a swing at it this semester. But like something like that would be like I'd hope that gets, an interview. I hope that's interesting enough to catch the eye of a recruiter. Um, but yeah, other than that, I don't know what to do. Um, yeah, I don't know. I mean, I guess the only thing like I said, the only thing I can think of doing is start reviewing topics more often and making sure I'm familiar with these topics. Doing more projects that escape my current skill set. Um, yeah, I don't know. So, but oh, also to add insult to injury, um, after that horrible interview, I was like, okay, I'm gonna go to the dining hall. My car is stuck. It is just stuck in the snow and ice. I can't get it out. It's just like spinning. I'm gonna have to call AAA probably tonight after this video. At midnight, have them come here and tow my car out of the snow and ice. And I have an 9 a.m. tomorrow, so it's like, yeah, I don't know. So that was terrible. That tipped me over the edge because I just came back in here and it was just like, I don't know. It's been a rough day. Um so so yeah. Um but let's get into LeetCode. Where's my control Z? Okay, not that. Okay. I'm gonna turn music on. Okay. Given a binary tree root, a node X in the tree is named good. In the path from a root to X, there is no nodes with a greater value than X. Return the number of good nodes in the binary tree. Uh, Obviously, it's depth first search. This music is so loud. Um, so obviously it's a depth first search. So we'll always start with a value of one. So I mean, I can say good. Um, I'm trying to think how this depth first search will go. Well, we know if I guess you just keep track of a path, right? So like I'd append 3, then I'd append 1, then I'd do this, and then if the left and right are both none, I check the current array and I make sure that starting from the last element going to the first, no element is greater than this, right? Than the last one. But at every step I do that. So like from 3 to 1 I do that, from 3 to 5 I do that. And I guess this would be good nodes is 0. We'll see about that. Um, but okay, so we do a DFS with root path, just root and path, I think. And then we'll end up, well, we'll do a DFS on root in an empty array. I want this to be node. Um, so we want to say if the current node dot left is none, and node dot right is none, then I want to say, okay, if actually, I don't think I have to do this. I think I just say return at the end. I mean, but what's the base case, right? Well, I guess I could do count as a parameter, and at the end I return count. Um, how do I say? So would I just say if node dot value is equal to the max between node dot value. I guess I would have to do. What if I do node dot value equals, or no, current is that, and something like this. What does this look like? Uh, oh, okay. How do you find how to find max element in there's got to be something easier than that. Oh, it's an empty sequence. Wait, do I do like what happens with this? Yeah, this is just so wrong. I need a pop at some point, right, though? I guess that would be like a case, is like if. Oh, I guess I need to do the pop after like this. Pop from an empty list. Cheers. I don't know. Just add all of this to it. I don't know what is this what is happening here. Root val and 0. If path, we do have path, so current is equal to 3. Max value is between, oh sorry. Node value is current, max value is the max in the path. So those are equal to the same thing. All right. So count gets incremented by 1, which is what we want. Okay. If left dot is not this, then DFS node dot left with the current path and count. So the current path should be just, oh, am I never appending? What am I doing? It should be I do a path dot append node dot val. Wait. Currently we have the current node in it. Do we want to append the thing that we're going into? So I'm going to 1, right? Yeah, I think so. So current and max value are just the exact same thing. Why would that be 3 and then 3? It should be node dot left, which would be 1. Why is it 3? Because like if I do this right here, per se. Three and 3. Beautiful. Then we go to 1 and 3. Okay, and then 3 and 3, so that's valid. Yes. Then we go to 4. Also print out path. So 3 is on, 3 and 1 is on, 3, 1, and 3 are on. All right, then we go all the way back and we pop, and then, ooh, 3 still needs to be on. Wait, If the current value is equal, the current value just has to be. Oh no, it doesn't have to be the max value. Never mind. Oh, no, uh, I am popping way too far back because that's like a five. Then we go to a four. That's no bueno. So that needs to be. Still don't know why this would be outputting one though. To be honest with you. Um, Let me see if this, because I think this would be correct if this comes back correctly. Invalid syntax. What? Count plus. Just increment, motherfucker. Why won't this just like. Oh, I don't know. Increment. Ah, real. I mean, what can I get around this with just doing not passing through a count and just having like down on the waist. Oh, this is gonna error a lot. Don't really want a return value here. This does not just work right now. Yeah, I was gonna say. Because right now, so this is 9-0-3-6. I think this is 9-3-6. So this is the greatest. This is invalid. And this is invalid, but we're only checking three. Is three the great? Yeah, no. So the whole thing is that I need to include this nine. I'm popping the nine off. What if I said if path is greater than one? I want a visual of this, man. This is ugly. I like what do you expect me to array to binary tree. Visual. Oh my God. Thank you. Oh my, can we please? Please. Oh my God, thank you. Let's only print the good ones again. Bussin. Okay, so two is good. 4 and 4, good. Well, this isn't possible. How this thing is making the tree. That's not what I have copied. It probably is. I'm just so mad right now. Oh my God, and then I canceled it immediately. Okay, so two is good, four is good, four is good. And then we go down the other side, which should still have good. It just says 2 and 4. And then we go to 2, 4, 1, which is invalid. So then 5, 5, yep, and then 5, 5 again. 4, 4, no, no. Why did it pop that 5? We have this 5. 2, 4, 1, 5. Wait. 2 4. Yeah. There should be 2 4 1 5 and then 2 4 1 5 5 right here. Why is that not? Why would that not be like what? Like what? It's not like I have a set here. And this goes to 2 4 1 4. But obviously that's not right because there's supposed to be a 5 there. Why is the 5 not there? I guess let's go through this whole thing. If path, like let's start at just having 2, right? And then we have I just don't get like right here. If I print off, notice how it says the left value is 5, which would have to mean we're at this node, right? And then we go into there. But this print should be 5 2 4 1 5 5 is what this print should be. Or with this, I'm so confused. I'm just gonna look at 1 second before we look at that. Let's look at this else statement. If node dot left is not none, right? So if at our current node, if this is not none, so at that 5, right? When I pass through that 5, if node dot left is not none, So like in that case, it is going to be the dot left is going to be none when we're at that five, right? So we pop that last value, which is not what we want to do. We just don't want to append it. But I still need popped values. It has to do with the popping. I only want to pop when I'm trying to like after I've appended this one, checked it. Maybe I have to maybe I append maybe I append the value before everything, right? Like what if before all this I did a what if I did the path dot append node dot value, right? Instead of doing it afterwards. So like when this first goes, right? Like if I did this and I just passed through an empty array and it goes through with root and root is 2. And so I append 2 and then I check if this value is, well, let's just check it. Maybe it's wrong, but still 8. Why is this popping like so wrong? When do I want to pop? I just don't get if this is actually the correct tree that it's talking about, right? Why wouldn't it like put this onto the stack and then check and it'd be like, yeah, that's good. Like I don't see. Problem isn't the logic for checking nodes. It's with how you're managing backtracking pop, for example. You do path out append. Wait. So it's saying no matter what, when we get back from this call, pop. No shot, right? No shot, right? What? Why? If no dot left is not none, call this. And so eventually we're going to get to the point where no dot left is not none. Okay. All this if path. Do I need to do? Well, if I'm appending here, we're always gonna have an if path, so fuck that. And then we're just checking if. I mean, I can just check with this now. A little better. So weird. So whenever we return from a call, so we get to the point where so we go all the way down, and then I get a left is none basically. So then we go and we pop that off, go back to the last stat thing, and no dot right. So what's gonna happen is we get to like that. What was it like a 2 1 4 5 5? When I get to that other five, right? It's gonna be none, and then we go here, and this is also gonna be none. So we go back to the last call stack, and then we go to after what this was, and we pop it off the path, and then we check if no dot right is not none, which it isn't at that point. So then we go down the right side, and then we go back through, and we check the left side if there is. If not, we go down the right again. So what was the alternative that I was doing? I was saying if no dot left is none. So I was going back in a recent call stack. I guess what it was doing is it was saying, oh, you know what it might have been is it was saying if when it got to like a bottom node, it was like okay if node dot left is not none, then path dot pop, and then it went again and it said if node dot right is not none, else path dot pop. Uh so it was doing a double pop in the case that we were at a leaf node. That makes sense. And so why were these ones passing in that case? I can't even see the visual, and I don't feel like seeing the visual. You can't see the visual. Don't tell me in like the test cases I could have seen it the whole time. Ugh. But so we'd get to 3 2 1, and then we do a double back. So I'd do like a pop, pop. And so now it didn't even matter because we already found the one path this way. Then we go this way, we find this path. And then we do a pop, pop. And then we go to 5, and so that's like good. So we'd find so it was just not. And then this one was obviously good because we were just passing it through once. And then this one we get here, good, good, pop, pop, bad. Wow. Yeah, that's crazy. We just had test cases, those 3 test cases that were just like they worked with that incomplete idea. Wow. Okay. Um what do I take away from this? Careful about your pops and backtracking. Motherfuckers in the downtown. God damn. Root and val. If root. Whoa, 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 whoa. We call solve with the current root and the current root dot value. Then we say if root, then k is equal to a recursive call on root dot left and the max between the value of the root dot value. Wow, I hate this. Affiliations. Oh wow, that is really simple. Just pass through the current root tree and say, hey, if this is greater than or equal to, yeah, that's actually good. I like that. So like to clean this up, like instead of doing an array here, I do like I'm honestly going to submit this to my GitHub because I like the solution of keeping track of a path. Um, but it's not needed. And I thought about that when I was doing this. Um, is it really 11? No. Oh my God, why did I think 22 was? Okay, yeah, so the idea is just no path, just a max. You think it doesn't like this? Max val. There you go, buddy. Um, and then instead of doing all of this, you just say if node dot value, and then you pass through uh, root dot val, and you say if do I start this at 1? I think I start this at 1. Um, if node dot value is greater than or equal to max val increment, otherwise no popping. Max val, max val. It's just this, right? I think. Is it starting at 0? Uh, what I do wrong? One time. What if not true? Node return. Really, you don't even have checks. I mean, I guess this is a check in its own. Okay, so that's not it. Oh, I'm so stupid. Oh my God. Max val is equal to this because this is now our max because it's greater than or equal to. Oh, so dumb. So dumb. I've been doing this my old way. Um, I don't even know if I want to do another. You know what? You know what we'll do? We'll start migrating some stuff over to these tasks and oh here, can delete this. Not like this fucking mattered. I anyways. Um I did this. Did I do this yet? I don't know. Yeah, I didn't think so. Back again. So this could be a little more efficient, eh? Also, just realized I have no way of like checking off tasks. That's probably something that should be done. Let's just do for the week. I want to do this whole thing. We'll just do that for now. You know, I kind of like this layout. I just want um number one, I should probably change these to like little icons up here. That's first off. I hate these big buttons. But I also want like same thing here. This should be like delete account, sure, but like log out should just be like well, actually no. That one, I think I'll put these side by side. Hmm. I don't know. That's actually a little more complicated. But I do want to make it that these aren't just like this view. in this view, I want it to be I either click task view or I click file view, and these determine, and then I'll have something like this for tasks where it'll like list all my tasks in like little blocks. I think that's what I want to do because this can be a little inefficient how I have this right here, um, but I also like how this looks. So, oh, the other thing I wanted to do, let me pause real quick while I bring it up. Okay, we have stuff to wait 1 second. We'll do the boring stuff first. We need to read over a few sections of computer architecture, so I can submit an assignment of questions, which I can also, um, one sec. Uh, um, I won't lie, this note thing on the actual like, nah, you gotta hear what just happened. Was I not paused? Don't judge my music taste, please. It's gas. Anyways, okay. Um, questions for sections 1.8 through 1.13 or 1.13. Okay. Such a banger song. Okay. Um, oh my God. Oh, nice. It is labeled. You think this will work on this? Nope. Okay, let's just make it less big, I guess. When we say one computer is faster than another one, what do we mean? The user of cell phones may say a computer is faster when a program runs in less time, while an Amazon.com administrator may say a computer is faster when it completes more transactions per hour. The cell phone user wants to reduce response time, the time between the start and completion of an event, also referred to as execution time. Okay, the operator of a WSC wants to increase throughput, the total amount of work done in a given time. And comparing to that alternatives, we often want to relate the performance of two different computers, say X and Y. The phrase X is faster than Y is used here to mean that the response time or execution time is lower on X than on Y for a given task. In particular, X is n times as fast as Y will mean execution time Y over execution time X is equal to n. Since execution time is reciprocal of performance, the following relationship holds. N is equal to the execution time Y over execution time X, which is equal to 1 over performance of Y, 1 over performance of X, which is, okay. The phrase throughput of X is 1.3 times as fast as Y signifies here that the number of tasks completed per unit time on computer X is 1.3 times the number completed on Y. Unfortunately, time is not always the metric quoted in comparing the performance of computers. Our position is that the only consistent and reliable measure of performance is the execution time of real programs, and that all proposed alternatives to time as the metric or to real programs as the items measured have eventually led to misleading claims or even mistakes in computer design. Even execution time can be defined in different ways depending on what we count. The most straightforward definition of time is called wall clock time, response time, or elapsed time, which is the latency to complete a task, including storage accesses, memory accesses, input-output activities, operating system overhead, everything. With multiprogramming, the processor works on another program while waiting for an I/O and may not necessarily minimize the elapsed time of one program. Thus, we need a term to consider the activity. CPU time recognizes the distinction and means the time the processor is computing, not including the time waiting for I/O or running the other programs. Clearly, the response time seen by the user is the elapsed time of the program, not the CPU time. Computer users who routinely run the same programs would be perfect candidates to evaluate a new computer. To evaluate a new system, the users would simply compare the execution time of their workloads, the mixture of programs and operation system commands that the user runs on the computer. Few are in this happy situation. However, most Most must rely on other methods to evaluate computers and often other evaluators, hoping that these methods will predict performance for their usage of a new computer. Uh, One approach is the benchmark programs, which are programs that many companies use to establish the relative performance of their computers. The best choice of benchmark measures performance in real-time applications such as Google Translate mentioned in Section 1.1 attempts at running programs that are much simpler than a real application have led to performance pitfalls examples. Kernels, which are small key pieces. Wait. Attempts at running programs that are much simpler than a real application have led to performance pitfalls. Kernels, toy programs, which are 100 lines from beginning program assignments, such as quicksort. Synthetic benchmarks, which are fake programs invented to match the profile or behavior of real applications. All three are discredited today, usually because the compiler, writer, and architect conspire to make the computer appear faster on these standard programs than on real applications. Regrettably for your authors who dropped the fallacy about using synthetic benchmark. Fourth edition of the book, since we all thought computer architects agreed it was dis the synthetic program Dystone is still the most widely quoted benchmark for embedded processors in 2017. Another issue is the conditions under which the benchmarks are won. One way to improve. So we've seen in dominant specific architectures often follow the third option. To uncover the data and placing tunes. Benchmark suites are a popular measure of performance. 1 second. Uh, um, 1 second. I won't lie. Um, um, I paused like 5 times. This is if we go to that's 27 pages that we are not reading right now. I'll read this tonight and in the morning. So this is the other thing I wanted to look at. Um, so this is a example of a proposal for the computer architecture class I'm taking. And I want to go through this because I haven't looked at this yet, and these are due next week. Okay. Architecture general purpose, its distinguished features. Architecture general purpose, but they call it the cardiac monitor. It's a slightly modified variant of the historical bell rev's cardiac. Okay. Word size is approximately 12 bits. We say approximately because the only supported data type is a 3-digit decimal, which we simulate with a binary encoding. The operation to be supported on the one type are add, subtract, left, or right logical shift. For registers, the cardiac is a single accumulator register for arithmetic, an instruction register, and a program counter. Wow, this is a minimal. Okay. The execution one was one address, fetching a single instruction per word. Uses a Princeton memory organization in its address unit. The address range, in keeping with the decimal data type, is 0 to 99. Load store. Clear and add memory to the accumulator is effective load. Store accumulator input to memory. They're just using one accumulator to do everything. Integer ALU. Add memory to accumulator. Subtract memory from accumulator. Okay, to support the matrix multiply benchmark, because it doesn't appear that there will be enough space in memory to support a multiplication between benchmark in the arrays, we will modify the instruction set so that the issues. And we build this into our assembler as a pseudocode operation. We will attempt to make a GUI that approximately represents the graphical design of the original cardiac. In addition to run and single-step modes, we will provide a manual mode of execution in which the user follows the prompts of the cardiac flowchart to move the. Wow. APIs for interfacing between memory and pipeline. Teamster 1 and Teamster 2. Sick. Pretty cool. A very simple architecture. Wow. Which, you know, kind of cool how much they're getting out of such a simple architecture. Okay. Well, that's all I got for today. Um, I just want to sleep my problems away. Pop 8 melatonin and not wake up. So, that was a joke, YouTube. Do not demonetize me. I don't make money on these videos. Anyways, that's really big. Okay. Um, so, um, yeah, like I said, today was horrible. I mean, I'll reflect on it and see where I need to, what the game plan is going to be because something needs to change. I mean, this is depressing. I won't lie. This is like really bad. Like I get no interviews for months and months and months, and then I get one for like, it's an intern's position at my school, and I bomb it. That's really bad. That's like really bad. So yeah, I need to figure out how to get my car unstuck as well. Before class at 9 a.m. So I'm probably gonna go outside and see if there's any sand that I can just like start shoveling under my tires. Um, Other than that, I got nothing. Probably gonna have to call AAA. So that's fun. Anyways, um, yeah, I got nothing else to really talk about. Tomorrow I have my 3 classes, so I'll be gone most of the day. Um, I'll probably record like tomorrow night. We'll do another LeetCode or two, depth first search, um, questions, and then I think I might work on the little on Quibly what you see in the background tomorrow, because there's stuff that needs to get worked on so I can start using this to my own personal advantage. Um, so yeah. Um, yeah. Okay. Well, that's it. Thank you for watching day 81. I will see you tomorrow for day 82. Uh, Take care. Bye.